So we are on the back page. If you take out your notes for, it says Chapter 2, Ionic and Covalent Bonding. In the very last page, we're going to do the very back part of the page where we had to name the covalent compounds. Okay, so we read the rules yesterday again for the second time. Now with covalent compounds, so we're going to write the descriptive name. They've given us what's called the chemical formula. Okay, so if you see something like a ClF3, that's the chemical formula. If I ask you to name the compound, then you'll write out the name. Does that make sense? Okay, so they're asking here under A, as we look at this, you've got ClF3. Okay, so what would that be named? How would I start naming that? What do I do to the first part? Just use its elemental name, chlorine. And then what do I do with the F3? Since it's covalent, I put a prefix on it, right? Good. Chlorine, trifluoride. Okay, that's not so hard. Chlorine, trifluoride. I don't know if I can type this on here or not. Let's see. Yeah. Oh, if I could type, I could. Okay. And then what happens with B? We got carbon, right?
Yeah.
What do I do with monoxide, right?
Yeah.
Because it's the second one. Okay, so that's pretty easy. But if I had, I'd never put the mono in front of the first element there. You what? What was your question? Monoxide? Did I not just type it right? Oh, sorry. Monoxide. Okay. So, and we're going to have problems of finding molar mass and using that. So let's go through the number 8 here. So we have to find the molar mass for CH2O. So that's not very difficult, is it? If we look at that, we have to look up what is the molar mass for carbon, right?
12.1.
Okay, so I got 12. Whoops. It's not letting me write. 12.1 is carbon. It's still not writing. Okay. I think I'll just talk about it, okay, because it's not writing it on here. 12.1 for carbon. What's hydrogen?
1.
Okay, so H2, so we got to multiply it by 2. So that's 2, and oxygen?
16.
16. So we have to take 12 plus 2 plus 16. Hopefully that equals 30. Okay, so the molar mass for CH2O is 30 grams per mole. Okay, so you could do that if I asked a question like that, right? Yeah, that's higher math here. All right, so for the K2CO3, we do it exactly the same way, wouldn't we? Okay, so what is the molecular or the molar weight for K? 39.1, so I've got to multiply that times 2. Carbon is 12, oxygen's 16, has to be multiplied by 3. So I would, whatever 39.1 is times 2, plus 12 plus 48, what did you come up with?
139.21.
139.21. And I didn't tell you how many places. But on the exam, we won't go more than 2 places either. I know on one of the problems here, it tells you to keep it to 1 place. So just follow what I say, okay, when we're rounding it off. Okay, so nobody has any questions on how to do that, right? That's perfectly clear as mud. Okay, so let's go on to question 9. Okay, we want to figure out how many grams of mercury there are in 0.666 moles of mercury. So what's the first thing I have to do? Look at my periodic chart, figure out what the molar weight of mercury is. 200.59 is the weight of a mole of mercury, with a mass, the molecular mass. Okay, so what would I do to figure out? I know that I've got 0.66 moles. I know that 1 mole weighs 200.59 grams. So really all I have to do is multiply 0.666 times 200.59 grams per mole of mercury, and hopefully you come out with 133.6 grams of mercury. Is that what everybody got? Everybody's going to get 100 on this test, I can tell by the way it's going, which is it makes me very happy. Okay, so no questions on that one? You're all asleep still on Tuesday? Okay, that's okay. I'll drink some more coffee and I won't be. I'm just feeling happy that the computer doesn't think I'm gone anymore. Yes.
What was the answer?
133.6? Is that what you got? Oh, that's okay. I don't hear things. Yes, I do hear things. I'm not going to tell you what I hear, okay? It would scare you. Okay. So, 10. How many moles of water are present in 50 grams of water?
Hey, Glenn, I have a question on number 9 with the answer. Like, there's 3 significant digits that they give you to start out with. So I just rounded up to 134.
That is fine.
So
that
on the
is
test, that's no problem.
No.
We don't really need to worry about that.
No, I didn't tell you to. Okay, if I don't specify that I want a specific number of significant digits, I just don't want you to go more than the maximum is 2 decimal points on the things, unless I tell you. So you actually, yes, you are correct in doing that. So that's fine. I can see your work. On the test, you're going to write down your work anyway, so I will not take off for that, because it's correct. I'm not going to take off if somebody has 4 significant digits there. Thank you for asking that question. Okay. If I asked you, make sure you write the correct number of significant digits, or how many significant digits are, then you have to be correct with that. So thank you for doing that. Okay, number 10. How many moles of water are present in 50.0 grams of water? You will need to calculate the molar mass of water to do this calculation, and you're supposed to use the atomic masses to 1 decimal place. So this answer, they want it to 1 decimal place. So what do I have to do? Molar mass of water? The molar mass of water is 18 because hydrogen is 1 times 2. Oxygen is 16. 16 plus 2, I hope, is 18. So you got 18 grams per mole of water. So if I've got 50 grams of water, I just need to divide 50 by 18, right? To find out how many moles there are there. And if you divide 50 by 18, you come out with 2.8 moles of water. Is that not what you got? Okay, see, you guys can do this all day, all the time. Okay, last problem on this page. We're supposed to calculate the number of moles that are in 48.9 grams of calcium chloride. And again, they want you to use the atomic masses to 1 decimal place, so we have to round off. So if we look up calcium, what is its molar weight? And we have to round to 1 decimal place, so 40.1, right? And chloride is what, 35.5? But you have to round to 1 decimal point. So this is where, like I said, you need to do it to 1 decimal point. So we've got 35.5 times 2 is 71. So we add 41.1 plus 71, and hopefully, did you get 111.1 grams per mole? Is that right?
Yes.
Okay. So again, same thing. We know we've got 48.9 grams of calcium chloride. There's 111.1 grams in a mole. So we divide 48.9 by 111.1 grams per mole, and you should come out with 0.4 moles of calcium chloride. Everybody can do these. Okay, it's not going to be any harder than that on the test, so no need to panic. All right, that's exactly the same kind of thing we're going to do. There'll be at least one problem like this. Okay, as I said, the test is 3 pages. You're going to have a section of conversions from English to metric. You're going to have to write elements down. You know, look at them and say what they name them. Or I'll give you the name and you'll have to write its symbol, but you can look right on your periodic table, right? Everything's on the periodic table. Okay, you might have to calculate molecular or molar weight. I'm trying to think of what's on the other side of that page that we did. We did some formulas for ionic compounds. You may have to do that. Covalent compounds. And we're going to start doing that with the next sheet we're going to do as well. So I'm going to close this one out. And let's, don't save. Let's go to the lab that we started on yesterday. Did you guys get the labs? Let me see if I brought them with me, if I left them in the office. I have too many papers here.
I have that.
No, that's math stuff. Okay, I have one here. No. I'll have to go back to the office to get it. Hang on just a second. I must have laid it down on. Oh, hang on. No, I did. They're here. No, those two. It doesn't matter. I didn't write on it yet. Okay, so yesterday, what we worked on, we started working on the, let me open up the lab on the computer too. We started working on the ionic portion of the lab, on nomenclature. And I think we got to page, because we named all the ions on pages 2 and 3. We went through page 5. So you started, for homework, you were working on writing the names, writing in the formula on one side of this chart. And then you were supposed to put the name of it on the other side of it. Okay, so we can go through a couple of these. If you look at the very first one on the top right-hand corner on page 7, I'll open this up so we can look at this on here too. Come on, thing. Okay. Okay, so this is where we're at. Oh, of course it'll shift back. There we go. Okay, so if we look at the far left on here, right up in this corner, we've got sodium on the left and hydroxide there, +1, -1. So it would just go together as NaOH, right? Okay, what would if we go just keep going to the right, sodium bromide would be the exact same, right? NaBr. What happens when we get to Na plus the SO4 -2? So it should, so because we have a -2 on the sulfate, we have to put a 2 on the sodium. So it becomes Na2SO4, correct?
Put the SO4 in parentheses, or is it just no that?
You can. I did. Just for my knowledge, you don't have to because you don't have a number behind it, do you? If I have a number behind it, I have to have it in parentheses because I need to know the whole thing is that way. Okay, And so we would do the same thing with sodium carbonate, right? We'd have to put a 2 on the sodium, and the carbonate would just be by itself. So really none of these were a big revelation, were they? So sodium nitrate would just be NaNO3. If we look at the sulfur, we've got an Na+1, S is a -2. So we've got to put a 2 on the sodium, right? And so it's Na2S. And then the last one in this column, we've got a sodium plus you've got the PO4 -3. So we have to put a lowercase 3 on the sodium, right? Na3PO4. Okay, was there, I mean, all these are done exactly the same way. Was there any of these that were tricky for you? I mean, if you just looked at the charges, it became pretty clear what we were doing, right? Am I correct? Yeah. Okay, I don't want to make an assumption. And you didn't have any trouble with the copper 2? Basically, it just meant it was a +2 charge because it could have more than one charge, and the iron 3 had a +3 charge. So if you see that Roman numeral, that's the charge on the metal if it has multiple charges.
But we don't need to include the Roman numeral in that formula.
You probably don't need to, because by looking at the other element it's combined with, you'll know that it's a +3. But they're telling you that it's a +3, so you get used to looking at it.
Yeah.
Okay. All right. So if that's okay, let's go ahead and turn over the page, and let's look at naming them. Okay. I know Balthazar wrote all the formulas again instead of writing the name, so poor guy. All right, so let's maybe just go down the first column. Well, they're all going to be the same. Let's go across then. You want to pick a different column? Who wants to pick what column we name? Nobody wants to pick? Well, let's just do the first. Okay, so the very first top left corner. What's the name for that? Sodium. The metal always goes first, and hydroxide is the OH. That's a little box to write that in, isn't it? Very small. So everything that goes across on the top line is all going to start with sodium, right? So you could put a repeat there. It's all going to be sodium, and then the second word is going to be the element plus an "ide" on the end. So it'll be sodium bromide. Although, now, this is where it changes. If I've got that polyatomic ion, I use the name of that polyatomic ion. So number 3 will be sodium sulfate. Okay, because it's not just a single element. So what would the next one be? Sodium carbonate.
Just carbonate?
Carbonate, sodium carbonate. And sodium nitrate. Okay, so if it's a polyatomic and not just a single ion, we have to use the name of the polyatomic ion. Okay, so I think we've got those. Is there anything tricky about any of the rest of these?
The second one from the bottom, is that ferric? Is that what
Okay, so 2 is us, 3 is it, right? So ferric oxide. So you are correct. So that whole thing would be ferric in front of everything. So and what is it? If you look up your Cu2+, what does that say on your ionic sheet? What is that? Cupric. Is there a cuprous too?
Yeah, there is, but
that's the Cu3. So is that opposite? That's opposite of what the iron is, isn't it?
Yeah.
So that's confusing. But you've got your sheet, okay? So you can look it up for the naming. Okay, I don't think there's anything else that was the only thing, and these are all ionic, so remember, with ionic compounds, no prefixes. Okay, that's what makes it easier. So if it's ionic, no prefixes. Okay. Any questions on that at all? I know that's a lot of busy work, but I figured by the time you finish with that, you know what you're talking about, right? All right, so the last thing that we want to work on today on this lab, because then our lab's going to be finished, if you're still going to keep them to study from for the exam, okay, is let's go through the covalent. How do we name these covalent compounds, which is on page 9 on the next page here. Oh, of course I'm going backwards. I'm doing very well. Okay, so we're right here. Okay, so if we look at the very first one, when we're naming a covalent compound, we name the first element, right? So that's sulfur.
Sulfur.
And then what's the second one?
Dioxide.
There you go. Okay, so when we go to the second one, we still name the first one exactly the same, right? Now what is it? Trioxide. So there's no big mystery to this at all. What about the third one? What do I do when I get to where I have 2 on the second, on the number 3? It's covalent. So now I have to use a prefix. So this would be nitrogen monoxide. Okay, so in the second one I have to put the mon in front of it. I got to get rid of all these. I didn't think it would keep. So dinitrogen monoxide. What would I do with number 4? Yeah, nitrogen monoxide. Are you with me, Matt? I figured you were going to be a little bit. I probably need to help you with some of this. Okay, so we got nitrogen monoxide. Okay, so let's go ahead and I'll have you work through the rest of these on your own as we go through, and I'll come by and see what you've got for each one of these. And if we have any questions, I just want to make sure. Let me turn the lights on for you. So you should have the prefixes on that conversion sheet. If you're, again, remember you can use that conversion sheet with your exam. So you should have everything you need in like 5 sheets in front of you, so that you don't have to be looking up stuff in the book, which is why I used it that way. I'm going to go ahead and stop this recording because I don't really need to go any further.